Good morning. This is James Little. I'm recording this video about a Wiley spectral webinar. I also did it for Wiley on their channel, but I wanted to also record one for my YouTube channel. So I want to share with the part one of it, the spectral searches with the NIST MS search. My name is James Little. I'm from Kingsport, Tennessee. I'm a retired research fellow from Eastman Chemical Company, and I had about 42 years experience doing unknown identification. I'm now a consultant for MS Interpretation Services. It's my own company, and I'm the only person that actually works in the company. I had a lot of specialties, and they were all somewhat related to identifying components in mixtures or doing reverse engineerings of products, etc. And they're on my webpage. If you want to look at them, you might find them useful for some other applications, but in general, they supported my identification by GC mass spec. Eastman Chemical Company has its main site in Kingsport, Tennessee, is where I work. There are about 50 manufacturing sites worldwide with 14,000 employees. But the most important thing with regard to this seminar is that we had 50 mass specs that were networked worldwide, that we shared files, we shared expertise, and we used mainly for our GCMS, we used the NIST search for identifying compounds and for also archiving our information to share with others on the network for user libraries. The webinar series will be broken into 5 parts. The first part will be the spectral searches with the NIST search, and then we'll do structure searches as another part of it, using MS Interpreter to correlate the substructures to the ions in the spectrum. AMDIS, this would be the third part. It's a very good program for processing very complex EI mass spectral data files. The fourth part is something somewhat new to the NIST search, is the hybrid search that I use a lot in my work, and I find very, very valuable. I want to share with you. And the last thing will be creating and sharing user EI and MS libraries, the things that we did at Eastman to make it more useful to share the information that we had with identifying things so that you could computer search it, and it was updated nightly. There are more information. This is just be an overview on the YouTube video, but the handouts really have the important parts about how to set up the parameters. To get the search to work properly, you need to know how to set up parameters. And I can't show you all of that today, but there's screenshots in the handout that I think you'll find very useful as you go through it. So what we want to talk about is the NIST mass spectrometry software with Wiley libraries. It's a free software suite. It's a lot of different applications for processing mass spectral data. It's supplied with the purchased commercial libraries or by instrument manufacturers. It's utilized with Wiley libraries for qualitative mass spectral analyses, as we'll demonstrate in this some of the screen sessions today. You can do both GC, EI, and LCMS unknown identification with the software. You can import the data from a variety of instrument manufacturers, just depending on whatever software you want to use to process the data, but you can also use AMDIS. It searches by spectrum, which we'll do today. Structure we'll talk about in the next session, but a lot of other parameters that you can also search by and limit the search. AMDIS is available for processing mass spectral data files, and if you can't to get your data file in that format, most of the manufacturers allow you to convert their data file formats into NetCDF or import into AMDIS. Mass spec interpreter we'll talk about for correlating molecular substructure to ions in the spectrum. Structure export and import using vendor drawing packages. You don't have to learn how to use another drawing package. You can learn the one that you're already, or you can use the one that you're already familiar with. So it's very important that you understand there's lots of help files with the software, and we'll talk about some of them today as far as seeing them, but they're available on my website. They're available by the help within the software itself, but you can also, if you hover over something, it shows you what it means too within the software, and I'll try to demonstrate that. The software is very Windows compliant, and it's important to use some of these shortcuts, if you want to say, for doing things, for selecting items or groups of items. The other thing is very useful after you do a search within the software, you can click on different tabs above it or different fields above it and resort the data, so you don't really have to research again or do something different. It just resorts the information based on that column, either going from the largest to the smallest, etc. So the first thing we'll want to do is do a tour of the system. So we'll go in and look at some of the basic windows now. The first thing I want to do is to kind of walk you through the windows. This is where you put in the things that you'll query, the unknowns that you want to search. So this is the spec list, they call it. You can see it has its spectrum and it has information about the compound that you brought in. This shows the libraries it searches over here on the left. Down on the bottom will be the results. So the fit will be based on 1,000, which we'll show in a minute. The middle display is very useful. You can show the results before your library hit on the bottom here and your unknown on the top, and you could either show it by difference or head to tail, side by side, and we'll do subtraction later to show the mixture. But I like head to tail probably the best. So let's start by doing a search first. Let's just do a simple search. Here's a spectrum that I brought in from another program. And to search it, the way I like to search something, but when it comes into focus from another program, it automatically searches, so you don't have to do anything. The results will already be there. But if you're in here and you want to search it again, just double left click on the entry that you want here, double left mouse button click, or you can go up to the go button, or you can right click and say library search. So if you right click on any window, it brings up a lot of different options for you. Now let's do the double left click and search it. You can see it's searching about, I think it's about over 1 million compounds you can see in this little window here. And the best hit is 2-ethyl hexanoic acid that we show here on the bottom. So some other things you can do with the display while you're here is you can change things, make it personalized for yourself, because more than one person might use the software, especially if it's sitting on a laboratory computer, but you can save your settings with your name so you can recall them. So a lot of things, so save some space, like up here in the top, I'm going to right click on this window. Anytime you want to change a window, just right click on it and say properties. I don't really like these ions here. They don't really add much to my characterization of the compound, so I'm going to get rid of that. So I got rid of that and said okay. You see they go away. Let's get rid of them in the bottom too. It's not very useful there either. Get rid of the intensity list there. Okay, so we straighten that up a little bit. If you decide you want a little bit more room over here, you can stretch the windows any way you want to. I don't really like the graph as much there. I like to know how many spectra I searched there, so you can bring that up. So we've kind of cleaned things up a little bit here. And when you get things like you want them, always go up and say File, Save Configuration. And then after that, when you want to use that configuration again, all you have to do is restore the configuration. So that's a real handy way to bring things back to where you know you should be when you're trying to decide if maybe someone else has used the software. Some other things you might want to bring in here. Let's go in and right click on here and say Properties. And another thing is the number of synonyms is kind of handy to have as a column. The number of other databases that the compound might be found in. So let's see if that brings that up right. So you can see it added those columns. Let's do the search again. Double left click on it. You'll notice here that the best hit is 992 out of 1,000. So that's always based on 1,000. But also when you find something, the number of synonyms that are correspond to it, the number of other databases it might be found in, give you an idea if it might be the most likely hit, because usually the things that have the most synonyms and have the most databases are the compounds that people see the most. So that's just another indication that you're doing, that what you got might be a reasonable search, especially if you're looking for the major components in a mixture. All right, so let's go up here and look through a couple of other things we have here. You can you see the little pluses here. If you expand those, that'll show you other things, replicates. So a lot of times on a different instrument, the spectrum might be slightly different. So you might want to get an idea of how other people see it. So as I click through them, you can see on the bottom, you can use your mouse button if you want to and step through them. I'm using not the mouse button, but the arrow keys on your keyboard. You can step through them very quickly, and you're always looking at the bottom here to see what the structure is. You're seeing the difference between the top and the bottom as you review things. But these are just replicates here. It'll also have derivatives to show you that someone's formed the TMS derivative of this. And also the tertiary butyl derivative. So you can, if you want to make that go away so you don't see those, just click the minus and it'll compress the menu again. All right, so let's go up to the top here and talk about a couple of things. That was the go button to make it search. That's to do structure searches, which we'll talk about next. It also keeps a history of things that you search, so you can always go back and see what your results were on something else. If you want to clean up that history, just say clear the history. Say yes. All right, this is the other way to expand the menu. Replicates off on, so you can see anytime you just kind of hover over something, it shows you an idea of what that function might do when you use it. And so replicates on and off, and you can see when I do that at the bottom, how the bottom menu expands. What it does is it just turns everything into pluses or minuses. They're expanding for every entry. The other thing that you do here is best matching only. A lot of times when you search like 2-ethylhexanoic acid, you can see that we have a bunch of them. We have 12 of them here that are just 2-ethylhexanoic acid. So if you click on this button here, it makes you see only the best matching only, and it uses the CAS number to do that. So the compound or the spectrum that has the best match, it'll show the CAS number for it and not all the other ones with the same CAS number. So I'm kind of getting that to, so you can see it simplifies the list. So now the second hit in the list, if you use your arrow buttons on your keyboard, is another isomer of it. So sometimes when you're looking through things, just don't look at the first hit, but step through several of them to make sure that that seems to be the best hit that correlates to your sample history and to your customers' expectations, etc. Always consider this is an aid to identification, and you should always think about other information you might know about the sample before reporting an identification for the component. So that's kind of handy just to show them the best matching. And those are pretty much the main settings in the main window there. The other, well, there's other tabs here, like in the bottom, I'm all the way at the bottom screen, you can say structures, and you can see things with the structure instead of the names. I'm kind of used to looking at names. I look at my structure over here in the spectrum, so I've already got that. So I like all these other pieces of information to show up. So I use the names tab there. But you can see there's other things at the bottom. So if you click here, the other search, there's a lot of things you can search by. If you go to the pull down menu at the top, you can see you can do molecular weight, formula, etc. But the best one, or the one that I use the most, is the sequential method. The sequential method lets you link things and limit the search based on more than one thing, like exact mass, name fragment, someone's name in the comment if you have your own user library, tags in the comment, etc. So that's a very, very powerful way to query the database if you want to know specific things. So I find that probably one of the more useful things. And maybe the other thing is maybe any peaks, if you're looking for certain peaks, spectra that might have certain peaks that you're interested in. So, so very valuable things there. The next thing over is probably one that people use a lot. It's the names tab. And the only thing that's funny about the names tab is you can only search one library at a time. So you can see here I'm doing the main lib, which happens to be the NIST lib. And I'm going to search aspirin. You'll notice as you type here, it does the search dynamically. And so it's bringing things up automatically. And so we're going to look at aspirin here. You'll notice aspirin at the bottom, it has, if you look, scroll through the names. I'm using my mouse button to scroll the display. There's 157 different names for aspirin. I find these common names for use with my customers, such as chemists and engineers, to be more useful than the IUPAC or the formal name. So that can be very valuable for doing that approach. You can also change the search so it only it uses numbers as part of the search, or it only uses the alphanumerics. So you can click the A to Z if you want to do that. But you'll notice over here when you do that, it'll say from the main lib. I'm up at the top. There are 29 different things that it thinks you might be interested in, but it doesn't really tell you very well what they are. I don't really like this display, but it tells you there are a lot of things to look at. So the best thing to do is just go over here on aspirin. I'm in the menu on the side. I'm going to right click on it. Remember I said right click always can do some additional things. I'm going to do a library search. on that material. So I'm doing a library search. It takes the other window back into focus. And now when you go to the top, of course, you searched aspirin. It sent it to the list and searched it. And you'll see that the top hit because it will be an exact match. And all you got to do now is do the plus for the pull down menu. And now you can see what all these 29 entries are. And I'm using the arrow keys on the keyboard to step down through them. So there are different replicates that people have acquired on different instruments, derivatives, the base acid instead of the acetate, different derivatives, etc. So that's a real handy way to expand what you can see in the names window. All right, so let's return to the bottom. So we talked about the names. We're on the bottom again. Compare is something that can be useful, and we'll talk about that more in structures. And the librarian is for creating your own library or editing the spectrum if you want to get rid of some ions and things. A librarian can do a lot of different things, but we'll talk about that in a later session. So let's go back to the top library search here. And the other thing I want to show you is just that it can do isotopes too. So I brought up a spectrum of acetone here. I'm searching it. I double left clicked on it to search it. And you can see that acetone is the top entry in the list because it was a reference spectrum of it. But now you can also see, I'm using the arrow keys, you can see the replicates, you can see a derivative of acetone, but you can also see the derivative, not the derivatives, but the isotopically labeled materials for acetone D6. So that's pretty much a basic description of everything in the software. So let's go back to the slides and see where we're at here. So we've done our basic tour here. Okay, so the other thing that you really have to get set up right in all of the library searches, and whether it be structure or library, etc., is you have to get the default parameters set up correctly and then save them so that you have them for the next time you use the software. And the critical software parameters relate to how the search is done. You can't really search 1 million compounds. There's about 1 million compounds in Wiley and the NIST library. If you search both libraries, it would take a very, very long time to be able to search all of those. So you have to do a pre-search. It looks at the major peaks in the spectrum and gets you a candidate list. And you can constrain that if you want to, and you can even turn the pre-search off if you want to and just search it without it. But it'll, instead of taking 4 or 5 seconds, it'll take minutes to do the search. So you need to do a pre-search, and it needs to do it well. And pretty much if you use the standard parameters, that won't be a problem. But if you get this pre-search candidate list, it gets a final search of candidates. And then after that, it does every peak in the spectrum of comparison, and it gives you a value based on sorting things based on 1,000. But you can also do some other constraints after the search if you want to. But the main thing is you just usually do a pre-search, finds a group of candidates, sorts the results, and then shows them to you. So that's the way it does it. Usually you'd use an identity search, but we will talk about the hybrid in a future webinar. Molecular weight, if you put it in, skips the pre-search and limits only the compounds that have a certain molecular weight. If you think it might not be working correctly, you could just limit it to the molecular weight of the compound that you're looking at, or the unknown. Usually pre-search default's the best, just use it. Pre-search off, like I said, skips the pre-search, but it will take over a minute to do the search, so that's not something you would want to routinely do for sure. Constraints results are filtered after the final search. So those are the key things, and I'm just going to go into the software again just to show you where those are, because it's important to know where those are found. If you come up here where it says Library Search Options, you need to click here, left clicking on it, and it'll bring up these menus. And if you go to my handouts, it'll show you how to set up all of these. But the main one are the search parameters. And you want to have automation on, so when it sends it in from another program, it automatically searches, so you don't have to click on it. You send it in from AMDIS, you send it in from the Agilent software, it'll just automatically search. You have your libraries. You can select bunches of libraries. I have 5 libraries with over 1 million spectra selected here for our demo today. Automation, we said, was on. Limits, you have to adjust some of those, but all of those are found in the handout. You need to go in and set them up. And again, let me emphasize, after you do that, always go up and save your configuration so that you want lose it. The first thing I do is when I look at a set of data, I search the solvent like acetone, methylene chloride, something that I know what the identity is, just to make sure everything's working. And let's talk about the other things it tells you when you search. Like if you double left click on that, it'll show you in the window what it's doing. But if you kind of look around at the bottom, you can see it says it was an identity search. The next type of search will be identity, and that's described in the software what the difference is, what it's telling here. But it also tells you at the top here, it did an identity search, it did a pre-search default, and it also found 33 spectra when it was through. So it tries to tell you a lot of different things about what it did. You can also go up here and say, view. I went up and said, hit list search options. It's up here on the menu. I clicked on it and it'll tell you what libraries it searched. So there's a lot of ways to check to make sure it did the right thing. There's one other thing I didn't set up in the windows when I first started here. Replicates, search options, tools, view. Mass to charge range. I like to set it at the min max of both spectra. I show that in the handout too, but that's a good way to save it before you save your configuration. So we pretty much got the configuration saved now. So let's go back to the PowerPoint. Talk a little bit more about some of the configuration settings that are important. So I showed you that you go to the Analyze setting, and like I said, all the options are in the handout. But what libraries do you want to pick? Well, that's a good question. Wiley has 815,000 entries, so I always pick it. I always pick the NIST library. It has 350,000. But I also pick my user libraries. We have 50,000 in ours, which sounds pretty small compared to the Wiley and the NIST, but those are things that are very important to us. There's things that we've identified in our products, other people's products, byproducts in our processes. So you can't downplay the importance of these user libraries. So which ones to search? In my opinion, I'd do all three. My user library, and I couldn't live without the Wiley, I couldn't live without the NIST. I have to have all three of them to make my job feasible. So what are these Wiley libraries and NIST libraries? Well, the Wiley 12 main is the best spectra for the component. The Wiley 12 replicate is what might look like on a different instrument, but might look more like what is on your instrument. So I select both of those. The lower quality, it's useful, but it's got less than 4 ions per spectrum. You might want to pick it, or you might not. But you can, if you set the parameters right, and that's shown in the handout. It shows you how to set them so that they'll still somewhat be useful, but they won't limit your search. The legacy are things that have been taken out due to quality concerns, but they're there in case you want to go from a historical point of view and see what might have changed. The main NIST library is one best entry selected for each component. Wiley has maybe more than one for the main and several for the replicate, but the NIST just has one, and it might or not be the correct or best one. So I usually have the replicate for the NIST turned on, then of course my user libraries. So what are some other libraries you might buy? There's a bunch of them, but I was just going to mention a few. There's 91,000 spectra in these separate libraries. You have to buy each one of them separately, and some of them look pretty small in size, but again, if it's something that's very pertinent to your work, then it can be very, very important to have these. A lot of people buy these extra libraries, and you can search I think it's over 100 libraries. You can search and combine the results. There's really no limitation on the number of libraries you can search within reason. Okay, so we're going to go back and do a couple more examples of something. Let's see, let's go back to the search here. Okay. I want to show you how to do a mixture. Usually gas chromatography usually separates things, but not always. Even on a capillary column, you still can get compounds to coalute, and then you need to somehow resolve them. Well, the software has got something built in to do that, and it's called a reverse search. Okay, so the first thing we need to do is add the reverse search menu option over here. So we're going to add it to the reverse match, they call it. We'll talk about that a little bit. Okay, so I've added the reverse match to my columns here. So I've added another compound, and I would save that to my configuration. What a reverse match is, let's bring up a spectrum here. We have a mixture here. If I was looking at this spectrum and I was a mass spec person, I might say, well, it looks a little busy to me. It looks like it might be a mixture. I see ions that don't appear to go together. Some of them don't look like the same classes. So what a reverse search is when you search this compound mixture up here, if it finds ions that are not in the library spectrum, or not in your spectrum, but not in the library spectrum, it doesn't penalize it. So let's say this 74 ion is in this mixture up here, but when it does the library fit, it goes and says, well, 74 I know it's there, but I'm going to ignore it as far as calculating the hit, the out of 1,000. So it ignores things that are in the sample that are not in the spectrum of the library. So you won't get penalized for having these extra ions. So that's the point of a reverse search. Don't get penalized for extra ions that are in your unknown versus the ones that are in the library. So let's search this mixture. So I've brought it in. I'm going to double left click on it and search it. If you go over here, I told you we didn't really talk much about match factors, but if usually it's 800 or above or so, it's got some possibilities. But if it gets below 700 or below 800, you have to start wondering if it really is what it says it is. So what I want to do, I've done the search by match and sorted by match, but I can sort by reverse match if I want to, and go to the top here. And so you can see I have a reverse match where it didn't penalize for the extra ions in my unknown that were in the spectrum. It's up in the 800s again. So that's probably a good hit. This cyclohexylamine, we show it in the bottom here. You can see it has a lot of the same ions. If we look at it, it's got the 138, 56, the 41, but you can see there's ions that are going up that are not in the reference spectrum. So it probably is, that component's probably in there, but there's something else. And what you can do is you can go down to here. Remember I showed you the different displays you can get? We can go down and we can go to the subtraction tab. And now what it does is it subtracts out whichever, if I select it over here, I'm going through the down keys on the keyboard. If you select the best hit over here, it shows you the differences at the top. So I'm just going to assume that the top one, the cyclohexylamine, is right. And I'm going to subtract it from the top, and what's left over is the difference. So here's probably it is the other spectrum of the other component here. It looks like something that weighs 200. Probably a methyl ester because it has a 74 ion is a base peak. But now you can just say right click on this. So right click and you can say library search. It's going to send it to the search menu and search that difference up here. And now what we've got, we can see that the match for the other component, this different spectrum, you can see it took out all the cyclohexylamine, has now a fit of 863, and the best hit is the methyl ester, as we thought it might be, of a fatty acid. So it's an easy way to do what we call a reverse search. And it's real handy if you think you might have a mixture and you don't have to figure out how to separate things on the column. You just use the software to separate things. So it can be very handy in some cases. So let's go back to the searches here, back to the PowerPoint, and find some more topics we want to talk. Display of related species. That's what I was telling you. When you pull the plus menu down, you can see if maybe it was a derivative, if it was the replicate, or if it was a isotopically labeled material. You can do that by turning on things. This determines if replicates are displayed or not. You can decide if you want to display as. You might just, if you turn it off to the default values, it only shows the replicate spectrum. It does not show the derivatives, and it does not show the isotopes. The only problem I've had with this is I think it's a little inconsistent in the menu. If you want to see the derivatives, you turn it on by clicking on it. And if you get the replicates by default, you don't have a choice about that. But to show the isotopes, you have to unclick it. And to see the stereoisomers, you have to unclick it. So I think they ought to both be, if you click it, you see it, but that's not the way it is. So beware of that. It confused me a little bit when I first started using it. And when you bring it up, like I said, by left clicking on the plus, you can expand things. In this case for cholesterol, you can see it's got the derivatives. It's also got some stereoisomers and other things. So I usually just like to display the replicates. I like to see the isotopes if I might use them to understand the fragmentation, and I like to see what derivatives might be present, but that's a personal choice. Inchi Key, they added something to the software several years ago, I guess. I'm not quite sure the year it came in, but you can see that here we have an Inchi Key. An Inchi Key is just a way to represent a structure in a hashed mode. It's not something you can use, but it can be used on internet searches to look for things, and it can be used to limit the search by the exact structure in some cases. So the Inchi Key is just a compressed form of the structure that's in a hashed mode that doesn't really mean anything to you, but it's very useful to the computer for binary type searches. You can double left mouse button, click on any of the Inchi keys in the NIST software, and you'll be taken to the PubChem. And the same thing for the Wiley, any of them that you find in the search, you can do that. And when you do that, it automatically carries you out to PubChem onto the internet. And then you can see other attributes about the compound that you're interested in. So I find that very useful. And you can also decide how the PubChem allows you to open it automatically or ask you every time before it goes to the internet, some options for that. Again, okay, this is the other thing. Sometimes you might have older libraries, maybe your structures haven't been updated, or you add another spectrum to your user library, then it needs to be updated. And they have ways to update. So if you go to Tools, and you can say rebuild the structure, you can rebuild it, different other indices, Inchi Key, other things that might need to be updated. And usually if your library is shown, or the library of interest is shown not in capitalized letters over here, then it's probably worthwhile to run the update. Doesn't take very long to do. All right, one thing that I had and some of my users have problems with at Eastman is that the library entries in the library are by nominal mass based on everything like hydrogen weighing 1, but hydrogen really doesn't weigh 1. The bromine weighs 79, doesn't quite weigh 79, but the library spectra are entered assuming that they do have these nominal masses. And for things lower than 500 or things that don't have a lot of bromines, chlorines, etc., not a problem. The nominal mass and the exact mass when they come into the program from another outside vendor will be the same. But that might not be the case for certain things. So there's this spectrum import options on the menu that allows you to correct things as they come in. And to do this, when you do that, you can correct things. You can correct the amount of mass that might be corrected to get it up to nominal mass. They have some suggestions here for things with hydrogens in it. Or if you're doing accurate mass, you can search, bring in accurate mass data, but you might want to limit the number of decimal places that it brings in. It will process accurate mass in the library search, but it searches as the nominal mass, but it can bring it in, and you can adjust that if you want to. But I'm going to show you a couple of examples. Certain things like multibrominated tend to be lower than nominal mass, and things with hydrogens tend to be higher. So you'll need to type in a correction factor here to fix that so that you'll do your search properly. If you don't, you can get very, very poor results if one of these compounds that does have a problem with nominal mass. And I want to show you some examples to kind of show you what I'm talking about. So in general, if it comes in below 0.5, like 536.5, it'll convert it to 537. If it's above 0.5, if it's below, it would go to 536 instead. And you got to be careful. Some data systems round before they bring them into the NIST. Depends on your manufacturer. Let's give an example here. Here's a compound, a multibrominated compound. The library thinks bromine has a molecular weight of 79, but the mass spec knows it really is 78.9. So if you bring it in as at the molecular ion that's at 949, and it'll be less than 0.5, it'll bring it in as 949, not 950. So if you want to correct this in the import option, you need to put 1.0087 to multiply by all the ions in the spectrum, and this will fix it. And like I said, it won't be a problem for like bromobenzene, which is a low molecular weight thing, but when you get up to higher masses, it will be a problem. So keep an eye on that. Keep an eye on your nominal mass and your that decimal place at the other side of the decimal in the mass. Maybe even a more common one, mass spec systems and chromatography systems have gotten good. You can get big compounds off the gas chromatographic column into the mass spec. And again, library thinks hydrogen has a molecular weight of 1, but the mass spec knows the molecular weight is really 1.0078. And so if you have a lot of hydrogens, something that weighs more than 500, like here, you can see that the nominal mass is 536.55. It'll round that up to 537, and that's not good because the library spectrum will have 536 as the molecular ion. So what you need to do in that import menu, you need to multiply all the values by 0.99888, and this will correct all your problems. If it weighs less than 500 or so, it will not be a problem whatsoever. Retention indices. NIST puts a lot of time into retention indices, and Wiley also has experimental or theoretical retention indices in their database. And you could use those as another way of limiting the searches. NIST converts, actually acquires retention indices with all the new spectra that they add to the database. And they use a calibration mixture. So you use a mixture of hydrocarbons, and you use those hydrocarbons to essentially calibrate the column with respect to your compound. So now you get a system independent number for every compound, this COVAT or retention indices. And you can use those. These are actually determined with the NIST MS software. You could do it yourself if you wanted to for your own compounds, but you limit the search using the search options. And it gives you additional orthogonal information for characterizing compounds. You might know that the spectra are very similar, and you don't know if you have the alpha versus the beta isomer, and if they have the retention indices are different enough that you can acquire it and get an experimental value that has a standard deviation that's reasonable, then you can tell if it is one or the other. So it's another way of people finding a good way to characterize their compounds when they don't have reference standards. And the mass spec search limits the search results list methods and conditions for all these determinations. So there's a lot of information about how it was acquired, the conditions in the software, and this part of the database. Sometimes if you show a lot of these, they'll come up when you do the search. And if you show too many of them, it'll slow down your search display. It doesn't slow down the search itself, but the display might be slow. So you might want to either turn them off if you're not using them, or maybe only show one or two of the different methods they use. And you can go and right click on the library search option menus, and you can change these parameters. The other thing some people like, you can go in and you can go to the top menu and you can do the derivative precursor option. And what that does is you can select how things are displayed for, let's say TMS derivatives or oxime derivatives. The only limit here is you can't show both. Like if you wanted to see silation in the TMS form, I'll show you here in a minute, or the tertiary butyl, you have to pick one or the other the way it is now. But when you do that, you'll see this is the display of the precursor derivative. It kind of just rips the TMS off so you can see the base molecule in the display, versus this would be the standard display over here. So if you like to get the TMS, maybe it's a little easier for you to see it that way, then that's an option. And like I said, you can only do one of the two. The other thing is the database, after it does the search, after you do the identity search, it can tell you things about the unknown even if it doesn't know what it is. So you go to this little icon here that looks like a magnifying glass, and you click on it, it'll come up and tell you the number of chlorines or bromines present and their probability. It'll tell you certain substructural parts, like if it contains a brominated phenyl group or a fluorine. It gives you an estimate of the molecular weight, and it's based on other things in the library search. So you have to do the library search first before this will work, but it give you ideas about things that you might not know the identity. So that's pretty much the end of the webinar. We've gotten to the end. This has been about 30 or 40 minutes, but the other things I have on my website are listed here, and they're all linked within the handouts, so you can see where they came from and where the internet links are. And so I think you might find this useful in some of your work if you want to know about these other topics. And they're also, the manuals are linked here. The different resources are also here. And it's just you can see if you just hover for a second, it shows you they're actually all internet links. I just wanted to tell people thank you. I had a lot of help in doing this with Wiley. And even though they didn't do this, they're the ones that got me to do this. And I wanted to thank them for their time and getting me organized to do these type of webinars. And the other thing that I wanted to do was to thank the people that helped me. David Sparkman helps me a lot in trying to get some ideas of what to present. And he also teaches some excellent courses on electron impact, electron ionization, GC mass spec interpretation. So if you want to go to him, he's a good resource for learning more about doing interpretation. And then Steve Stein, I really appreciate all of his help. He's the head of NIST, and he made all this software possible through his efforts and his very talented team that developed all this software. So in summary, I hope you'll find this useful. This is just a start in a long journey for you. You first learn how to set up the software properly with the right settings, but then after that, it never really stops, because if you can get better at interpreting the data yourself, that's important. So learn, find some resource books, go to the internet, learn how to interpret things, but always be skeptical of what comes up in the search. It's just so easy to push that button and get the results, but always consider the sample history. Where did it come from? Does it make any sense? Talk to your customer. If it's something strange, you might either want to buy a standard or maybe prepare a small sample of the material in a mixture. You don't have to separate it, just give a reaction that gives an enhanced amount of the compound of interest by known chemistry. You might want to do that, but don't just send out the identities without making sure that they are logical, because after a while your customers will lose confidence in you if you don't do your job diligently. So thank you for your time.